Hello. This video is going to look at the definition of the radian and its relationship to the radius, and then we will be able to end up with conversions so that we can go from one system of rotation to another. So here's a definition. The radian is the rotation, and remember, rotation is movement that it pivots around a point like this, right? The rotation needed to generate an arc length of one radius for any given circle, regardless of the size of the circle. Now here, please note that what we have is a definition that involves rotation, right, which is the radian, and a length, a distance. So we're looking at two very different kinds of movement, all right? So here then I have a circle, and here's the radius, r. And what I'm going to do is I'm going to ask the question, how many times will the radius go into the circumference? Okay, so that is, if I were to walk, for example, the distance of the radius, and I were also to walk the distance of the circumference, how much greater, how many times greater would the circumference be than the radius? Well, what I'm going to do is lay this little piece of string here, which is the size of the radius, and then I'm going to wrap it around the circle starting at this point here. And what I do, I'm going to mark it and say, okay, here's one radius. Now obviously this isn't super precise. This is really just to show you the concept. Now this is the length, the arc length is 1 radius, which is a length. But what we know by definition is this is what? If I rotate from here, right, from 0 to this position, I've just rotated 1 radian because of the definition that bridges the two, right? Now what I'm going to do is keep going, and I'm going to say, okay, here's my little piece of string. It's the size of a radius, right? So here's one more radius right there. And we're going to keep doing this. Here's another one, and so on and so forth until we can finally get all the way around the circle. Here's another one. And you may want to do this for yourself, just to prove it. The more senses that you involve in learning, the stronger and the deeper the learning occurs. Okay? All right. So it looks like it went in 1, 2, 3, 4, 5, 6, and a little bit. Now that little bit is a portion of the size of the radius, and it'll turn out to be 0.28 if it were very exact. So how many times did the radius go into the circumference? About 6.28. All right. Now what that means is how many radians did I actually go, because every time I generated a radius, it's because I also would have the corresponding rotation of 1 radian. So that would be 6.28 radians to go 1 revolution around the circle. So another way of asking this is to say, how many times will the radius go into the circumference? But remember, the circumference is 2 pi r. So now what you can see is the radius cancels out, and you're left with 2 pi. And remember, pi is, since pi is about 3.14, then you have 2 times 3.14, which is, you know, your 6.28. And of course, this is an approximation because we're approximating pi. But essentially then what we know is going around the circle in terms of rotation, we know is 360 degrees. It's also 1 revolution, and now we know it is also what? 2 pi radians, right? About 6.28 radians. Here's one of them, 2 of them, 3 of them, 4 of them, 5 of them, 6 of them, and a little bit. That's 6.28 radians. And if I would just want to be precise, I would say 2 pi radians. Right? Where a radian is that rotation. Okay. So now let me just give you the equivalencies. So we know that 1 revolution equals 360 degrees, which is also equal to 2 pi understood radians. Okay? So that when you go to do any kind of conversions, you can use, remember you multiply by 1, so you could say 1 revolution over 360 degrees is an equivalency, or you could say 360 degrees over 1 revolution, right? That's also 1, because they're the same amount of rotation. So the same amount of rotation over itself is 1. You could say 1 revolution is 2 pi, or 2 pi over 1 revolution. And of course you could say 360 degrees is equivalent to 2 pi, or 2 pi is equivalent to 360. All of these are going to be used as your equivalency. Okay? So now, let me just finish up with this, that what you'll find is the revolution of 1 radian, so from here to here, right, is going to generate 1 arc length regardless of the size of the circle. So you can see here that, for example, the radius of this small circle is small, so its arc length that it generates is small, but it's still the same rotation as, for example, when I rotate out to the large circle. Right? So I rotate 1 radian, but since this radius is larger, so is this arc length. Right? Now you should go ahead and see, pause the video and see what is 1 radian in degrees. How many degrees? Right? So pause the video and go ahead and find that out, and then we'll go through it. So 1 radian, remember when I multiply by 1, I want to go out of radians, so I'm going to say 2 pi understood radians is 360 degrees. And of course you could use pi as 180, you could do that too. You should get about 57.3 degrees. All right. Thanks for listening.